Hi there. Hope you're doing good. So we are in track 2 today, in continuation with Python introduction that we have done in track 1. So I'll be covering quickly, the rest of the topics that I had to, to cover up the introductory pieces of Python coding. Okay. So I'm assuming that, whatever we are going to cover today would be little advanced, but still I'm making it very, very short and crisp because the intention is to only introduce you the topics and make sure you're comfortable for the later tracks where I actually use them in the use cases that we are going to cover up. So that's the main intention of this particular introductory sessions. I'm making it very, very crisp and straight, not too many examples, because when I explain you the use cases, definitely you will come to know. All right, so let me take you through the code that I have for you. So I think you're good now to load up the project every time you want to learn this. So I have your track to the code open ready for you. So this is the code, not that piece. So the topics that I have got for you guys in this track is to introduce you functions, UDF and Lambda, and then comprehensions like list and dict, which is like the hot in the market today that you should definitely know, and then classes for object-oriented programming, and then inheritance. How can you inherit a class into a different class, and then different types of variables. I think in track one we have covered what is variable, but now I wanted to differentiate between local variables and global variables, which is again very important to know. Then how do we deal with dates? A very, very basic dealing with dates. We would be dealing much more complex in the tracks that you going to come up later. And then importantly, regular expressions. How do you extract a pattern that you wanted to extract from a given string? And then lastly, how do you deal with files? You know, uh, when I'm talking about files, it means if you have a data in the external files, how do you load them into your system and how do you write something into the files, etc. That's what I meant there. Okay, so this is the overall thing that I'm going to cover. Again, as I tell you in, as I told you in the last introductory session as well, in case if you're good with the, Python basic coding, you can avoid this. You can skip this particular session and directly jump into the tracks that you're really interested in. Okay, so the tracks are there in the playlist, and then you can choose what you wanted to actually look in, whether engineering or data science related, or the web related and the automation related, whatever. I'm going to put it in the playlist, so you can choose to skip this session as well. Okay, so let me now get into the pieces. Let's start with the function. A function is nothing but it's a user-defined function. People call it UDF as well sometimes. So in case if you have a set of steps or a program that you wanted to continuously access, you don't want to code those step of lines again and again whenever you want to use them, right? Instead, what do we do is we create one function and we just call that function that can run the same job again and again for us. So, so if to create a function in Python, the syntax is you have to just say def. Anything which is starting with def is a function. So this is the name of the function that you can write any name of your wish. And in case if you're passing some arguments inside the function or the parameters inside the function, you will have to specify what should be the name of that parameter that is called inside that function only. So so whatever I'm going to pass. So and then if I have to write set of codes inside the function, everything that is separated by the first indentation is part of that function. What I mean is even if I type something in double indentation here, so print and I say indentation, so this is also part of the same function. Okay, but this will fail because it should be here until unless there is an if condition, right? The indentation to be used inside Python is for a purpose. So is to start a loop, is to start a while loop, start a for loop, start a def function, start a classes, something like that. Only then indentations has to be used, else you should not use it. If I'm just saying 0 equals 0, then print this. That's it. So this is the end of my function. So this will always be true and I'll get this print. Okay. So to load this, I think in the last session, in the introductory session, I have shown you how to make sure your selection runs in the Python console in the bottom. So just select this and then say command enter on my command written on my Mac. So you can choose your shortcuts that you have set. So just say command enter. That means this definition, this function is ready for you to consume. So now how do you use the function, right? So I'm passing some input inside this function. This input will be called as the variable name input inside this function. So that's why if I print input inside the function, it will be the same thing that I have here. See, passed in value, right, is or skill Python intro. But here if you see in the print, I said print whatever is the input. So what happens in the backend is this particular string will be called as input is equals to, right, this one inside the function. That is what is going to happen inside the function. Okay, so and then when you say print input inside the function, because this is a variable which is assigned automatically with this command, you're going to see that. And because this condition is always true, you will also see the print of indentation as well. And the reason of creating a function is reusability. If you want to reuse it again with a different input text, you run it again, you see the same thing here as you code. Remember, this is a very, very basic, definition of a function and an example of a function, but we are going to create complex and, functions in the tracks, use case tracks for sure. So, you have to be just ready for that. I'm making you ready, that's it. And the next type of functions are called anonymous functions. It's called Lambda functions. It's a very, very famous today. Even on AWS Lambda instances, Lambda functions is a service that is provided by Amazon and any cloud structure, probably cloud infrastructures at the moment. So Lambda is an anonymous function. In case if you don't want to create a function and keep it persistent, when I say persistent, this function is available in the memory, in the kernel of the server until you exit. In case if you don't want a function to be available inside the kernel, but if you have a set of program that you want to run again and again over the object, you can create an anonymous function called Lambda. Okay, so how does it work? So first of all, I'm creating a list and I'm calling this as a Lambda function. And if you see this, just run f of x. So that means I'm passing an input variable called x for x in a. So x in a is nothing but 1, 2, 3, 4, 5. So for each of these 1, 2, 3, 4, 5, as we have learned the for loop, this function will execute. So f of 1, comma f of 2, comma f of 3, comma f of 4, comma f of 5. So what is f of 1? I'm saying 1 into 1. What is f of 2? I'm saying 2 into 2. What is f of 3? 3 into 3. What is f of 4? 4 into 4. What is f of 5? 5 into 5. So once I execute these two, what is the list that I'm going to get? So this is the list that I'm going to get, which is nothing but 1, 4, 9, 16, 25. Right? As simple as that. So your coding becomes very, very easy and simple once you start coding in Python. Right? So it is very simple. So if you want to write the same in a conventional way of writing a for loop, this is how it is. So it is nothing but for x in a, right, print f of x. Right? This is the same thing that is written here, but this is called list comprehension. Right? So let me run this and then you will see the output. See, 1, 2, 3, 1, 4, 9, 16, 25. It's the same thing. But what I did here is to give you the braces, parentheses, so that each of the output is automatically put into a list. That's the reason this output is one line after the other, but this output is directly in the form of a list of outputs. So this is nothing but the list comprehensions. So you can call a function and automatically the output of all the values of that function will be given to you as a list. Right? That's why it is called as a list comprehension. So this particular command is nothing but the equivalent is this. This line 14 and 15 is the conventional way of writing a for loop. But now the things changed. You can write it like this, as simple as this. But the output would be a list comprehensions. Only comprehensions can be written like this. Okay. So I'll also show you the shortcuts of if loop also. So here for the list comprehension, what am I saying here? For x in range 10, if x percentile 2, that means the remainder once you divide with 0, right? Once you divide with 2 is 0, only then you multiply, sorry, double star asterisk means square of it. So if range 10 will create a list of elements from 0 to 9. So what it happens is 0 percentile 2, 1 percentile 2, 2 percentile 2 is 0. So definitely it matches. That means 2 power 2, it becomes 4. That's my output. And again 3 percentile 2 is not 0. So it skips. So only if this condition is true, then x to the power 2 is what executed. Again, if you want me to convert the same list comprehension into a conventional way of writing it, this is what it happens. For x in range of 10, right? This is how you write a for loop. If x percentile of 2 is equals to 0, that means the remainder is 0, then print x power 2. This is what it happens. So now if I execute this, see the output. So 0, 4, 16, 36, 24. So inside the for loop I have an if loop also. But instead if I run this command, you see everything is in the form of a list. The same output is in the form of a list. That's it. And I can create nested loops as well. So for loop, a for loop inside another for loop. It's the same thing as writing this. For x in this, okay. So again I write another for loop. If you observe carefully, once you start another nested loop, you get double indentations automatically. This is what your PyCharm will help you to do it. Else it is difficult. In your terminal, Python terminal, you have to manually take care of this stuff. Alright. So now I'm writing it as it was. So this one, and then I say x into y. Print it. Okay. So that you see it on the screen. As simple as this. It's the same thing. 3 lines of code. I have written it like this, but the output is also in the form of a list. But this output is not in the form of a list. It is one after the other, right? 40, 80, 120, etc. But if I do this, you see, everything is in the form of a list. I'm sorry, some typo. So everything, just the variable value is in the form of a list. So another thing that I forgot to tell you guys, in case if you create a variable and if you want to, see the variable value, you need not always say print the variable. Instead, select this variable and then say command enter, or right click and say execute selection Python console. It will give you the value of it. This is like a shortcut. This is what called as, if the output that you are creating is a list, it is called list comprehension. Instead, if you are creating an output as a form of dictionary, it is called Dict comprehensions. So I'm creating a dictionary for you, and I'll help you recollect what is Dict as we covered in the last track number 1. So Dict is similar to JSON object where you will definitely have a key and value, right? So here the key is A, 15, B, 12, A, uppercase A is 8, lower uppercase Z is 7. Now I'm writing a comprehension to it. What am I saying? For the object, right? For the K lower, that means I'm changing every key to lower. What am I saying is, get lower after you convert all the keys into lower. Okay, if you don't find a key, mark it 0. You add the same with whatever you have it with uppercase. So for K in object.keys. Okay, so what actually this one will give you as an output? That's what you should know first, right? So I'll help you to do that. So once you execute this, you only get the keys of the dictionary. What am I saying? For all the keys in this dictionary, you basically sum if it is lowercase and both uppercase, and finally convert into a lowercase, right? So now let me copy paste this. Now if I give you this output, see, A is 23, B is 12, Z is 7. But why A is 23? Because 15 plus 8 became 23. But there is no other key with the name B. So 12 plus 0 is 12, right? And there is no another key called Z. So 7 plus 0 is 7. That's the reason this is the output. So I wrote my own functions based on the keys also. This is called Dict comprehensions. So if the output is a dictionary, it is called Dict comprehensions. That's it. Okay. So next comes the classes. So class is very important for you, when you deal with object oriented programming. That means you create a class. Inside the class you can have n number of functions, n number of loops, n number of things. Why we use classes is just like UDF. If you have a set of program that you want to run again and again, you create a user defined function, right? But if you have the complete, code that is set of 20 different functions, 30 different functions, 10 different loops, etc. If you have a set of code that should be reusable by, n different kernels, then you create a class object. The same class object can be called 10 different times. All of that you have specified in that class can be reused. Okay, and I have a very good example, a classic example coming up in track 3, which shows you the classes that we are going to consume. So what is a class? Class is set of objects, that's it, and reusable, right? You can parallelly call the same class in 10 different kernels and then execute your program. Okay, and then if I create a class, this is the syntax, and again it's very similar to your function. And this is like, you create object is nothing but the test. Once I say what is the value inside the object, there is a variable called orskill. So what is the value of it? It's 1. That's what I have given here, right? The next one is class inheritance. It's nothing but I can create one class and I can inherit everything inside the class into another class, right? And if I just say object with this class and then say orskill underscore 1, it is giving you 10. Though I called child class but not the parent class, because I have inherited parent into the child, so this is available inside my child as well. This is called class inheritances. Alright, so now let me tell you, I think I have created an object called a in the earlier steps. So I'm deleting the variable called a. Now I will define you what is a global variable and local variable. Now if I execute this function, what does it do? It goes and creates this variable, right? But it executes it, but this a value is not available for you outside the function. So any variables inside the function are local variables to that function itself. If you want this variable to be accessible outside the function as well, so you will have to create the function like this. The only difference is you have to specify that whatever variable you are going to see next with the name a, it is a global variable. Now because I created this function, I'm running this function. Now you see the output of this function, it's 2. So a variable inside the function is not defaultly available outside the function. In case if you want that outside the function, you have to say it as global variable. Okay. And then next comes import date time. For example, if you want to know the system time or if you want to deal with the time, there is a module available that comes by default in your Python kernel called as date time. Import that module. Inside that module, if you just say x equal to datetime.now, it will give you what is the time today, right? That's it. So there are a very complex use cases which needs date functions to learn more, which I don't want to cover today or in this session or in this track, sorry. You will be covered about all of those combinations as and when you see the use cases, right? That will be covered for sure. Next, regular expressions. In case if you want to extract a part of string which falls into one pattern, if you want to extract that, you can use regular expressions, and the module that will be available by default in every Python installation is RE. If you just import this into your kernel, and I'm saying a string variable as the rain in Spain, and I'm saying anything that starts, uppercase is anything that starts with D, and then it can have any number of characters in between, but it should end with Spain because I'm giving a percentile here, sorry, a dollar here. That's what it is. In the variable called text, that is what is my x. Now if I see x, what is the value? It matches, and it matches the rain in Spain. Because the matches here, Spain also matches here, that's the reason it matched. Okay. In case if I want to see the output, if I say dot match, now you see, I'm sorry, you will have to deal it with separately, which anyway don't worry, it is going to come up in the next track. I have this, a very good use case of regular expression. You will see that there. Alright, so now if you want to create a file, you open up a file in the current track, which is called demo file 2, and A is nothing but append mode. That means I can start writing content into this file. So if I just say f equal to open a file and then start writing some content into the file, right? So write, you know, second line of the file, right? If you open up any file, it's important for you to close. Only once you close, it will be available in this directory. Let's see that. Until then, you don't see the file name here. See, it is in the memory itself. Now, if I close this, see, it should be available here in a second because PyCharm will take a second to actually sync up. Else, I would just right click and say, synchronize, right? You got the file, see? Now, if I want to read the file which is already existing, not writing, you just say open again the same thing, but read mode. So if I just say file and read everything in the file, you see, now the file has more content and you have second line of the file, everything you can read on the screen. All right. So I think that is it. I wanted to actually explain you guys through this session, with which I wanted to conclude the Python introductory pieces. It's a very, very simple introductory pieces, believe me, because I believe in use case examples and learning. So that's what is going to come up for you in the next coming tracks. All right. Okay. I think you have, l- liking the video sessions. In case, please send me a feedback. You can write a comment on this video in case if you have any feedback. I'm happy to take it up and try to improvise and give more informations that you would need. All right. Okay. Thank you guys. See you in the next track. Bye bye.